it's Mrs. Morin. So let's continue to explore partitioning our shapes into equal shares or parts. And I want you to look at the pictures that I have here, the diagrams, and maybe even you can take a piece of paper and some pencil and you can kind of draw them as we're talking about them. But up here in my first group, it's my halves, or two equal parts. And equal means they are the same sizes, right? So if I took this triangle and measured it against that triangle, although they're facing different ways, they are equal in size. And the same thing with these two triangles and these two triangles and these two triangles. When you put them together, if you measured both of them, they're two equal parts. Okay, same thing here with the trapezoid, right? I got a trapezoid up here, and facing the other way I have an equal trapezoid, but it's two equal parts. Here I have thirds, or three equal shares. 1, 2, 3, 1, 2, 3. And once again, sometimes the eyes can be a little deceiving, right? They don't look like they're equal shares, but if you measured them, they would be, all right? Here's fourths, 4 equal shares. Okay, 1, 2, 3, 4. But I look at this one here, and how is this one different from the other three? Let's divide it into thirds. 1, 2, 3. Partitioned into thirds, 3 different parts. But are they equal? No, they're not equal shares. So it's not really 1/3, 1/3, 1/3. It's divided into 3 different sections, but they aren't equal in size or equal shares. So let's go on. So let's analyze these together. Which ones are partitioned into 2 parts? And which ones are partitioned into 2 equal parts? So let's look at them, right? And let's see. I see 1, 2, that's 2 parts. 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 So they're all partitioned into 2 parts, and I would encourage you to write them, draw them on a piece of paper, and actually look at them very closely. If I folded here on this line, those 2 half circles would fit on each other. So I know they are 2 equal parts. And if I folded on this line, the 2 triangles would fit on each other, so I know they're 2 equal parts. But if I folded here, this part would not cover this part exactly. So although it's partitioned into 2 parts, it's not partitioned into 2 equal parts. And let's look here. 1, 2, 3, 4, 5, 6, a hexagon divided in half gives me 2 trapezoids, 2 equal parts. So this one is not divided into 2 equal parts. So let's do more divided in into halves, right? And we are now looking to see which ones are equally partitioned. So I see, let's make sure that they're have 2 parts. 1, 2, 1, 2, 1, 2, 1, 2. Can you look at that and tell me which one, just looking at them, which one looks like if you fold it on the dotted line, it's not going to cover the other side? Let's check it out. Those 2 triangles look identical or the same, 2 equal parts. Those 2 triangles look like although they're pointed in different directions, if I folded it, it would fit on each other. Now this one looks a little suspicious, right? Because this is so small and this is so big. If I folded it over, I don't think that would fit on there. And if I do this, there's my hexagon divided in half again, gives me 2 equal parts. So this one is not equally partitioned. It is not divided into halves. So now let's look at which ones are partitioned into 3 parts. And then we'll try to figure out which ones are divided into 3 equal parts. That's a different question, right? So let's look. Let's count. 1, 2, 3. That's 3 parts. 1, 2, 3. 1, 2, 3. Now we have to look at it and say, which ones would be equal parts? So if we fold it on those lines, would that fold into like a little book? Yeah, it looks like they would cover each other. This one would fold that way, this one would fold that way. Yep, they look like they are equal parts, not just 3 parts. Now let's look here. If we divide this, we do that on the dotted line and we fold over and fold over, that's not going to fit perfectly on there. So although this is divided into 3 parts, it is not 3 equal parts. Now but here, this almost looks like a die, right? Let's see. We have the diamond. It's like the number cube, right? There we go, there we go. Those look like 3 equal parts. I could cut this out, cut that out, and put them on top of each other, right? And they would fit. So this one is not divided into 3 equal parts, although it is partitioned into 3 sections. Now let's work with thirds. Which ones are partitioned into equal thirds? Well, first of all, let's see what's divided into thirds, I should say. 1, 2, 3 parts. 1, 2, 3 parts. 1, 2, 3 parts. Right? So I got all 3 of them. They're divided into 3 sections, but are they equal parts? So let's analyze them. This line here, this line here, and we can see that these 2 shapes here, this and this, do not match the middle section. So this is not partitioned into equal thirds. But let's look here. If I cut that, and if I cut there, could I put this one on that one and move that one over? Would it fit right on it? Are they divided into equal thirds? They sure look that way. All right. And let's look at this. We have one big triangle, and it looks like it's divided into 3 small triangles that are equal thirds. Cut them out, they would fit on each other. So how about the fourths? Which ones are partitioned into 4 sections, and which ones are equally partitioned into fourths? So let's do a quick count. 1, 2, 3, 4 sections. 1, 2, 3, 4 sections. 1, 2, 3, 4. Now, which one of those looks like it might not be equally partitioned? Let's use our little drawing tool here, right? Goes down. First, I divide it in half. All right, well, we're off to a good start. But then it goes all the way down toward that end. And I can see that this is much smaller than that side. And this is much smaller than that side. So that is not equally partitioned. But let's look here. If I cut there, partition there, partition there. If I cut them out, fold them over, it's going to fit exactly on the opposite side. Okay, so that is equally partitioned into fourths. And how about this? 1 second rectangle, third rectangle. I could cut them and put them on top of each other or fold them up, right? So when we look at it, this one is not equally partitioned. So let's take a few more shapes, okay, and see if they are equally partitioned into fourths. So these are all cut into four sections, I'll tell you that now. But let's look at them and draw our lines and imagine cutting them. And I encourage you to draw with me. And the question is, does this match this, match this, match this? Is that equally partitioned into fourths? And I have to say, no way. But let's look at the next one. All right, now it's cutting that way, that way, that way. That is definitely into equal fourths. And how about the circle? Remember the other circle we just did where it was kind of cut high up, making these sections, some of them small and some of them large. This one looks like it goes right across, and I have 4 equal sections. This one is equally partitioned into fourths, and so is this one. So what did we do today? We are looking at shapes to see how they are partitioned, and then we are looking to see if they were equally partitioned. And we can see here it's divided 3 ways, and this triangle is going to equal this triangle, is going to equal that triangle. So this is equally partitioned into thirds, and we can even add one more triangle here that is exactly the same size and see that they are equally partitioned into fourths. All right, have a good time with this, and I'll see you soon. Bye-bye.